Hey everyone, in this video we're going to go over the 2010 AP Physics C Mechanics Free Response question number 1. So the question says, students are to conduct an experiment to investigate the relationship between the terminal speed of a stack of falling paper coffee filters and its mass. The procedure involves stacking a number of coffee filters like the ones shown in the figure above and dropping the stack from rest. The students change the number of filters in the stack to vary the mass m while keeping the shape of the stack the same. As a stack of coffee filters falls, there's an air resistance, drag force, acting on the filters. So here's part A. Part A basically says the students suspect that the drag force Fd is proportional to the square of the speed v, so Fd is equal to cv squared, where c is a constant. And using this relationship, we have to derive an expression relating the terminal speed vt to the mass m. So what I've drawn here is a free body diagram. And in general, so always objects that are falling down, they're always going to have a force of gravity acting on them. So here I have mg, which is the force of gravity, as always. They also say that there's a drag force. Drag force always opposes the direction of motion by definition. So here, since this thing is falling down, Ft is going to be pointing up. And also because this thing is falling down, we're going to take the bottom downwards direction as positive. Therefore, this is a free body diagram, right? So mg is going to be positive. It's because it's in the positive direction. Fd is going to be negative because it's opposing the motion. It's in the negative direction. So if we look at this equation for the net force here, we have that mg minus f of Fd is equal to ma. Fd is equal to cv squared as given in the problem. So you've got mg minus cv squared is equal to ma. They ask for v, the terminal speed vt, so we can just plug that into here. We also have to note that at v is equal to vt, a is going to be equal to 0. And that's because once it reaches its terminal speed, that's its max speed. It's not going to get any bigger than that. The velocity is always going to remain the same, which means that acceleration is 0, because acceleration by definition is the change in velocity over the change in time. But if the velocity is not changing, the acceleration is just going to be 0. So we have that this side of the equation is 0, and then we can solve for, we can add this to this side, and we can say that mg is equal to cvt squared, and then we can solve for vt squared, which will give us mg over c. So that's the relationship between vt and the mass. So here's part B. Part B says, assuming the functional relationship for the drag force above, use the grid below to plot a linear graph as a function of m to verify the relationship. Use the empty boxes in the data table as appropriate to record any calculated values you're graphing. Label the vertical axes as appropriate, or axis as appropriate, and place numbers on both axes. So I've copied the data table here again, and you can see that I filled it out with vt squared. That's because if we look at the equation that we found in part A, we had that vt squared is equal to mg over c, and if we just rearrange this a little bit, we can just put parentheses around this, we'll see that vt squared is equal to g over c times m, and g over c is basically a constant. This looks very similar to the equation for linear graphs. The general equation for a linear function is y is equal to ax plus b, where a is the slope and b is the y-intercept. So this equation, if we compare it to this one, we can see that y is equal to vt squared, a is equal to g over c, because g over c is a constant, and just like the slope, and the slope is also constant. So a is equal to g over c, m is equal to x, because m is a dependent variable. That's the thing that we're changing. So so x is equal to m, and then b is just equal to 0, because there's no constant added here. So this equation is very similar to this one, which means that we can think about y as vt squared. So what we want on this vertical axis here is vt squared. So we just have to solve for vt squared using the given values for vt. We just square this, 0.51 squared is 0.26, and do the same thing for the rest. And then once we get that, we can use m. We have the values of m already given to us, and they've put that on the x-axis here. I just added the times 10 to the negative third to make it easier for us, because we can just look for 1.12 and just plot all these points. 1.12 is right there, and at that point vt squared is 0.26, and you just do the same thing for all the other points. And then they ask us for a linear relationship, so we can just draw this best fit line. You just want it to follow the general trend. You obviously can't go through every point, But you just want to make it like in this direction where we have like an equal number of points above or below. Since there are 5, it's fine. You can have like 2 points above, 3 points below. But you know, around that point is like general. So that's all for part 1. For part 2, they want us to use the graph to calculate C. So remember when I said here, A is the slope. And the slope, if you relate it to this one, is equal to G over C. So if slope is equal to G over C, we can solve for C to get C is equal to G over the slope. We have this graph here. From this graph, we can calculate the slope. We can just take any 2 points and use rise over run to find the slope. I just took this 4.4, 0.95, and then 1.4 and 0.3. And just did rise over run, just a basic slope calculation from that graph. And I got 217 meters squared per kilogram second squared. And then I plugged it back into this equation. C is equal to 9.8 over 217. Remember, G is always going to equal to 9.8 meters per second squared because it's a constant it's a universal constant. It's always going to be that. So C is equal to 0.045 kilograms per meter. You should get something around that value. It doesn't really matter if it's like slightly off because in the AP exam, they usually accept a range of values because it's just an approximation.